So this is a very quick unit. We're going to talk about how to perform operations on functions. And of course, the four main operations are addition, subtraction, multiplication, and division. And so we're going to do it algebraically. We're going to do it graphically. We're going to see how the domain is affected when we combine functions by one of the four operations. And then we're going to look at a special type of operation, quote unquote, in the last lesson. So if we've got two functions, one called f of x, one called g of x, okay? If we want to add the functions, we create a new function called h of x, and all you do is you add the function f of x to the function g of x. So you'll see it look like that. Or sometimes it looks like this. They mean the same thing. So when you see that notation, you are asked to add two functions together. For a difference, you can create a new function, let's just call it k of x, by subtracting f of x by g of x. Or it may look like this, f minus g of x. Again, those two mean the same thing.
Does it have to be h?
Not necessarily, if you think about it.
Okay.
So here's two functions. One's 2x plus 1, the other's x squared. You are asked to add them together. So you create a new function by adding f of x, which is 2x plus 1. To g of x, which is x squared. Well, you can't combine anything. There's no like terms. So I can just get rid of the parentheses and we're done. That's it.
Are you not gonna do the parentheses?
We don't need to. Yeah. I mean, you could if you wanted to.
It doesn't say solve.
What's that?
It doesn't say solve.
Doesn't say so. One thing you can be asked is to find the domain of the combined function. Well, think about it this way. If you were to graph this, what would it look like? What shape would it be?
Yeah.
Yeah, so it would be a, no, what would the shape be if it's a linear? A line. And what's the domain of any line?
Negative 3 would be that.
If you were to graph this one, what would it look like?
Parabola.
A parabola. What's the domain of any parabola?
Negative 3.
So if I'm going to combine some function that has a domain of everything with another function that has a domain of everything, then the sum must have a domain of everything. That's it. That's not going to be the case all the time, but we'll see how it works when we do a few more questions. Okay? Another question you could be asked is you found the sum function. Now find when f plus g of x of -4. So what does that mean? Plug -4 in for x, into this function. So we're going to get -4 squared plus 2 times -4 plus 1, and then we just calculate it. So we get 16 minus 8 plus 1, which is 9. What about, oh, sorry, not the graph, yeah. Here we have another one. We're given two functions, and we're asked to find the equation of the function, combined function, if we subtract these two, f minus g. This one, you got to be a little bit careful, because remember, when you plug them in, you're going to get root x minus 1 So we're going to put in f of x in parentheses minus g of x in parentheses. Well, you got to be careful with this. I can take out the parentheses here and nothing changes. But when I take out the parentheses here, something changes because I have to subtract everything inside. So I get subtract x plus 2. You can't combine anything or simplify anything any further, so you're done. What about the domain if we combine them by subtraction? Well, we have to find the domain of each one. What kind of shape is root x minus 1? Right, it's this, right? What's the domain of that?
Whatever the point is to infinity.
Well,
Yes.
yes. So remember, if it's root x, it starts at 0 and goes to infinity. But this starts 1 to the right. So it goes 1 to infinity. The range, sorry, the domain of g of x, again, there's no square root, so it's a line. So it's negative infinity to positive infinity. What do they have in common? -1 to infinity, right? Like this one goes forever both ways, but this one only starts as 1. So what they have in common is what you write. 1 to infinity. Finally, you're asked to evaluate the difference function by finding f of 0. So I got to put 0 in every time I see an x. So I get root 0 minus 1 plus 2.
Would it not be minus 0? Would it not be minus 0? No, wait. It says minus 1.
What's the square root of -1?
You can't make it.
Right. So you can't do this.
But the second number is -1. Would it not be negative?
Oh, sorry. It would become plus 1.
Why? Would it not be?
Oh, wait. I had that right. Okay. it doesn't matter what this is.
I know. But it would have to be. Shouldn't the one be there?
Oh, for God's sake. I got you. I figured it out. Thank you. There. Still,
No solution.
no solution. Because you can't take the square root of -1. Okay, the last thing we're going to look at, what if you're given the graphs of the functions and you're asked to graph the combined function by addition or subtraction? So for example, these two. This is the graph of f of x. This is the graph of g of x. You only graph the portion that each of them have in common for the domain. Okay? Like for example, don't write this down. If this one had an arrow going this way, we would only graph from here to here because that's the domain they have in common. Okay? But if we notice, they have the same domain in common. So what I want to do to graph it is I want to pick relevant points. And notice you're given 5 points where x is -8, where x is -4, where x is -2, x is 0, x is 1, and x is 4. Okay. For x equals -8, remember, f of x needs the y value, right? So what's the y value at 8, x equals 8? 2. What's the y value at g of x? -8. We add those together. And you get -6. So that's a point on the new function, -8, -6. And then you do that for all the points we listed. So at -4, 2 plus -8 again gives us -6. -2 is 4 for f of x. -4 for g of x. Add those two together, I get 0. 0 is 0 for y, or for f of x. And -6. So that gives me -6. For 1, it's -2 for f of x. -7 gives me -9. And then finally for 4, I get the same 2, right?
Yeah.
-2 plus -7 gives me -9. And then all you do is plot those new points and draw the shape. Okay, so we're going to have -8, -6. So -8, -6 would be there. -4, -6. And then I'm going to connect as I go. -2, 0. 0, -6. 1, -9. Down there. And 4, -9. So that's what f plus g looks like. And so that's f plus g. For subtraction, you do the same thing, except you find the difference between the y values of the two functions. So for example, here we're given two functions, but what you should do to start, only start with what they have in common, their domains. This is part of f of x, but there's no graph on g of x that's has x equals negative 6, 7, 8, 9. So I only want to start what's in common in their domain. So I'm only going to do that. So we've got -5, -3, 0,
-3. Oh, 100. No.
3, and 6. Now remember, watch your subtraction. When you subtract a negative, yep.
How do we have 6 if it's not in?
Oh, sorry, not 6. Just 3. It's cut off. Now watch when you subtract, because if you subtract a negative value, that's addition. So the y at f of x when x is -5 is 2 minus whatever the y value at g of x is, -8. So it's 2 minus -8, which gives us 10. -3, 1 minus -8 again gives us 9. 0, y for f of x is -2 minus -4, which gives us +2. And finally, for 3, we have -2 minus -7, which gives us 5. Plot those points and connect. So -5, 10, -3, 9, 0, 2, and 3, 5. So it's going to go like this, then down, and then bounce back up a little bit. That's it. Okay, and this is the graph of f of x minus g of x. And then the final example. Notice these are given in set notation. So the domain of f of x is everything less than 2. The domain of g of x is everything greater than -7. What's the domain of their combined by addition? Right, because if you think of f of x, think of f of x starts at 2 and goes like that. G of x starts at -7 down here and goes like that. So what's in common? Everything from -7 to +2. So we would just write this. Or you could write it like this if you want to use set notation. It doesn't matter. Both are correct. Okay. Okay.